We will start with concept of conventional current. Let us say that we have a battery of voltage V volt which is connected across a resistor of R ohm. Long side of the battery is your positive terminal and small side of the battery is your negative terminal. It is called as the high voltage side and this one is your low voltage side. So conventional current states the current flow from positive terminal to negative terminal. It is from high voltage side to low voltage side. This is your conventional current. It is just like the flow of water which flows from high position to low position. Conventional current is used in all electrical circuit analysis. It is accepted worldwide. This direction of current accepted worldwide. It is from high voltage side to low voltage side. This convention ensures that all engineers, students and technicians can understand and communicate about the circuit in the same way. Conventional current I is your ratio of charge to time taken. It is charge divided by time taken. Unit of current is in amps. It is ampere. Unit of charge is always measured in coulomb and time is measured in second. So conventional current or current is nothing but ratio of charge to time taken. Next, let's discuss what is potential and voltage. Potential or electric potential is defined as the ratio of potential energy to charge. This is your potential, or you can say electric potential. Potential is given by symbol V and its unit is volt. Therefore, V is equal to PE divided by Q. It is potential energy divided by charge. Unit of potential energy is in joule and unit of charge is measured in coulomb. So we can say 1 volt of electric potential is equal to 1 joule of potential energy divided by 1 coulomb of charge. Likewise, electric potential of 10 volt is equal to 10 joule of potential energy divided by 1 coulomb of charge, which is equivalent to 20 joule of potential energy divided by 2 coulomb of charge. That means 1 coulomb of charge has potential energy of 10 joule or 2 coulomb of charge has potential energy of 20 joule. Hence, electric potential or potential is the ratio of potential energy per unit charge. Next, let's discuss about voltage. Potential energy divided by charge is your electric potential. What is voltage? Next, voltage is your electric potential difference. Okay, say for example, we have a resistor R which is connected across 2 points B and A. VB is your potential at point B and VA is your potential at point A. So change in potential or electric potential difference is given by symbol delta V. Delta represent any change. Okay, so delta or del V is equal to V of B minus V of A. Del V is your difference in potential at point B and potential at point A, or you can say potential of point B with respect to potential at point A. Point B with respect to point A. This is given by V of BA. Similarly, we have the formula for V of AB. It is potential of point A with respect to point B is equal to V of A minus V of B. Let us try to understand this with the help of a numerical example. We have a resistor R which is connected across 2 points A and B. Given V of B is equal to 100 volt and V of A is equal to 20 volt. So change in potential, or you can say electric potential difference, V of BA is equal to V of B minus V of A, which comes as V of VA as given in the question. We have V of A is equal to 100 volt and V of A is equal to minus 20. So V of BA comes as 80 volt. Hence, voltage is defined as any change in electric potential or electric potential difference between 2 points. So this was all about electric potential and electric potential difference, which you can say as voltage. We will discuss about resistance and resistivity. What is a resistance? It is defined as the property of a material due to which it opposes the flow of electric current. Property of a material due to which it opposes the flow of electric current is your resistance. This is R and this is the current. So this is the property of a material due to which it opposes the flow of electric current. Any opposition is your resistance. Opposition upward to the flow of electric current is your resistance. Resistance is denoted by R and its unit is ohm. Next, what is law of resistance? 4 things. First is resistance R is directly proportional to the length of the conductor. Second is it is inversely proportional to cross-sectional area. Third is it depends on nature of material. And fourth one is It also depends on temperature of conductor. Now let us derive the formula for resistance and resistivity from the law of resistance. By neglecting this last condition, so R is directly proportional to length of the conductor and it is inversely proportional to cross-sectional area, or R is equal to rho L by A, where rho is a constant which is called resistivity, or you can say specific resistance. This is your equation 1. From equation 1, we can derive the unit for resistivity. From equation 1, rho will be equal to R multiplied by A divided by L. As we know, unit of R is ohm, unit of cross-sectional area A is meter square, and unit of length is in meter. So R is in ohm multiplied by cross-sectional area meter square. This is length in meter. So this meter got cancelled, and the unit of resistivity will be ohm meter. Hence, resistivity is defined as the property of a material that measures how strongly it resists the flow of current. How strongly it resists the flow of current is your resistivity, and resistance is the property of a material due to which it opposes the flow of electric current. Resistance opposes the flow of electric current, and resistivity is the property of a material that measures how strongly it resists the flow of electric current. Let us try to understand the resistance and resistivity with the help of a numerical problem. We have a copper wire having resistance of 8 ohm, length is equal to 2 meter, and cross-sectional area is equal to 0.5 meter square. Question for you is, what is the resistivity? This is the question. As we know, the formula for resistance R is equal to rho L by A, where rho is your resistivity. From this formula, we found resistivity as R multiplied, this will go up, so R multiplied by A divided by L. Now putting the values of resistance, cross-sectional area and length from the above given values in this equation, R is 8 ohm, area is 0.5 meter square and length is 2 meter. So this comes as 2 multiplied by 4 is equal to 8. So 4 multiplied by 0.5. This comes as 2 ohm meter. So resistivity of the conductor comes as 2 ohm meter.